So what if you could prove something was true, not by trusting a person or a company, but by trusting the actual laws of physics? Well, today we're diving into a system that does exactly that. We're talking about an identity literally forged in the fabric of reality itself. Okay, so here's the fundamental problem we're all up against. Our entire world, everything from our power grids to our supply chains, it all runs on data. But here's the thing, digital data is ridiculously easy to copy, to change, or to just completely fake. So how in the world can we build our most critical real-world infrastructure on a foundation that might just be a total lie? For basically all of history, our solution has been centralized trust, right? We rely on a single authority, a king, a bank, a big tech company, to tell us what's what. But that model, well, it has a glaring single point of failure. The alternative is something totally different, decentralized trust. Instead of relying on some authority, it relies on verifiable math and physics. And look, this isn't just a different model. It's a completely new philosophy of truth. And this gets us to a challenge that has honestly stumped engineers for decades. It's known as the Oracle problem, this immense difficulty of getting a secure, decentralized digital system to actually trust information that comes from the messy, chaotic, and super easily faked physical world. And the stakes here could not be higher. If a sensor on a food shipment can be hacked to report a false temperature, people can get sick. If an energy meter can be spoofed, the entire grid could become unstable. We're not just talking about spreadsheets here. This is about the physical reality that we all depend on every single day. So to really get our heads around the solution, let's meet our hero for this explainer, an autonomous delivery pod called the Curb Car. Now, the Curb Car's identity isn't some username or password that can be stolen. No, its identity is its physical self. This whole thing is possible because of a concept called the hardware root of trust. Essentially, it anchors a digital identity directly to the unique physical properties of an object. The goal is simple, but it's profound. Make cloning a device's digital identity just as hard as cloning the physical device itself. Two key pieces of tech make this whole thing work. First, there's radio frequency fingerprinting. It analyzes the tiny, microscopic imperfections in the device's radio circuits, creating this unique, unspoofable radio hum. Think of it like a device's own unique accent. Then you've got a trusted platform module, or a TPM chip. This gives all the data a unique cryptographic signature, using a key that is literally burned into the hardware so it can never be copied. So one verifies the body, the other verifies its voice. All right, so our Curb Car has this provably unique, rock-solid identity. Now what? Well, let's follow it on a journey. As it moves through the world, every single step it takes, every network node it talks to, it creates a verifiable cryptographic trail of breadcrumbs. This is done using something called an exit visa protocol. As the Curb Car leaves one node's range, that node signs a digital visa that basically says, hey, Curb Car 734 left my area at this exact nanosecond. Then when it arrives at the next node, it presents this visa. The new node verifies it, proving that the vehicle physically traveled between those 2 points. It creates this unbroken, provable chain of custody. But what happens when the system comes under a direct attack? Okay, let's bring in our villain, a hacker who is about to try and break the system by doing the one thing it is designed to prevent: being in 2 places at once. This is a classic move called a Sybil attack. The hacker has somehow managed to create a perfect software clone of our Curb Car's identity. It's got the right credentials, the right keys, everything looks legit. Their goal is to have this digital ghost exist on the network at the exact same time as the real thing. So here's the scenario. The real physical Curb Car is out making a delivery in Arizona. Meanwhile, hundreds of miles away in Texas, the hacker's software clone tries to connect to a local network node pretending to be that very same vehicle. So the node in Texas gets the connection request. It checks the clone's credentials and, yep, they look perfect. But then it checks one more thing. And this is the moment the entire system pivots. Instead of just a simple access denied message, it detects something far more fundamental. So here's how it works. The network uses what's called spatio-temporal validation. It knows the Curb Car's last verified location was in Arizona. It calculates the distance to Texas and the time that's passed since its last check-in, and the math is clear. The vehicle would have had to travel at an impossible speed, literally faster than is physically possible, to be in both places. So the clone isn't rejected because of a bad password, it's rejected for violating the laws of physics. Now, this is absolutely incredible for securing machines, but where do people fit into all this? I mean, how does a human operator, say a maintenance tech, prove their authority in a system that's designed to trust no one? Well, the solution is something called a sovereign badge. Think of it like a unique digital credential, an NFT that acts like a digital diploma or a pilot's license. This special soul-bound token lives in a digital wallet, and it proves an operator is certified. And because it's soul-bound, it is permanently tied to its owner. You can't sell it, you can't trade it, you can't just give it away. It's yours.
This creates a perfect chain of command. For any critical action, like a firmware update, the system requires two signatures. The machine signs with its TPM chip, which proves which machine is involved, and the human signs with their sovereign badge, proving who authorized it. This dual-signed object creates a perfectly auditable record, cryptographically tying a specific person to a specific piece of hardware.
Okay, so let's zoom out for a second. A vehicle that can't be cloned is really impressive for sure, but the implications of this technology are absolutely massive. This is about building an entirely new foundation for our physical infrastructure. So why does all this matter so much? Well, first, it finally solves the Oracle problem, bridging that gap between digital proofs and physical truth. Second, it enables something called spherical resilience, allowing critical infrastructure to run securely in an island mode, totally offline. And finally, it creates things like provable supply chains and a zero-gas economy, where industrial systems can log huge amounts of data without the crazy transaction fees you often see with traditional blockchains. There's this quote from the source material that just captures the essence of this whole paradigm shift perfectly. We have replaced fallible human authority with the indisputable laws of math and physics. It's a fundamental move away from trusting people and toward trusting the basic laws of the universe itself. And that really leaves us with one last big question. Once we can truly trust that our digital records actually reflect physical reality, what becomes possible? I mean, what kind of world could we build on a foundation made not of trust, but of truth?